Hi all. Today we'll be discussing the LeetCode problem of the day, transformed array. So here you're given an integer array of size n, and you have to return an array of same size, and you have to fill the resultant array as follows. So suppose you have an index I. So in nums you have index I. So in result of I, you have to fill the value such that if in your nums of I the value is a positive number, then from I you have to move this three times right side. So I plus 1, I plus 2, I plus 3. So maybe here you have a number 7. So you're at I and you moved 3 positions to the right and you land at 7. So the number where you land, that number you have to insert it in your result of I. And suppose if your nums of I is negative, let's say if it's minus 2, then instead of moving to the right by two units, you have to move to the left by 2 units. So I minus 1 and I minus 2. And let's say at I minus 2, you have the value 3. So in your result of I, you will insert 3. And last case is where if your nums of I is 0, then result of I will also be 0. So no change. And also note that this array is in circular order. That means suppose here you have 5. So you have to move 5 steps to the right. So maybe after 4th step, you reach the end of the array. So from here, if you move to the right, you will again circle back to the starting. So it keeps going like this. And similarly, if you keep moving to the left, when you're at index 0 and you keep moving one more time to the left, then you will come back to the end of the array. So yeah, at the end, you just have to return the resultant array. And given the note, since number is circular, moving past the last element wraps around and it comes to the beginning. And same thing from the starting, it wraps around to the back. Now let's look at the input, first input. First array is 3, minus 2, 1, and 1. So you will create a resultant array of same size. And first, let me write the index also. Yeah. Starting with index 0. So the value is 3 and it's positive. So you have to move 3 steps to the right. So 1, 2, 3. So you'll end up at this position. And here the value is 1. So you'll insert 1 here. Now your I equal to, when your I is here, the value is negative. And since it's negative, you have to move 2 steps to the left side. So 1 step will reach to index 0. And after this, if you go to the left, it will loop back to the end of the array. So again, the value will be 1 because you end up at this position, this value. Then after this, I'll check for this value. And since it's positive, I move 1 step to the right and I end up at again number 1. So I fill 1 here. And finally, when I'm at here, I is nums of I is positive. So I move 1 step to the right, and moving to the right from the last will lead back to the starting. So I end up at 3. So here I'll fill 3. This is your resultant array 1, 1, 1, 3, and that is your output. Now let's take a look at second example. You have minus 1, 4, and minus 1. And you'll create a resultant array. Yeah. So first you're at here and it's a negative number. So you move 1 step to the left. So when you move to the left, you will arrive at this point. So you'll have a minus 1 here. Now you have a 4. So you have to move 4 steps to the right. So 1 step here. Then in second step, you will loop back to the starting. Then third step, again, you will reach 4. And then last step, you will reach to minus 1. So 4 is, this index is done. Finally, for the last index, the value is minus 1. So you'll move 1 step to the left and you'll end up at 4. So the value to be filled is 4. This is your final array, minus 1, 4. And that is your output. Coming to the constraints, the array size will be from 1 to 100. And all the values in the array will be from minus 100 to plus 100. Now let's go over the approach. So suppose your array size is 5 and you'll have indexes 0, 1, 2, 3, and 4. And let's say you're at index 1. So when you're at index 1, if you move one step to the right, you'll reach 2. Then after 2 steps, you'll reach 3. After 3 steps, you'll reach 4. Then after 4 steps, you'll reach again 0. And after 5 steps, you'll again reach to the same number. So that means for I equal to 1, after 5 steps, it is same as not moving anywhere. And again, if you move 10 steps, then again you'll end up at the same position as again. So from this, we can say that we just need the remainder when we divide the number of steps with the array length. Because after every array length size of steps, you will end up at the same position. So if you have to move total 13 steps, instead of manually jumping 13 steps forward, you can just take 13 modulo the array size, which is 5. So 13 mod 5 will actually give you 3. So this basically means moving 13 times to the right is same as moving 3 steps to the right. So you will end up at position 4. The same thing can be argued for the negative as well. So if you move 5 steps to the left, you'll again end up at this point. So the approach is pretty simple. You are starting at index I, and you have to move nums of I times to the right. So the final index where you will arrive is I plus nums of I. And since this value will keep looping around, we just need to take a mod with the array length, which is the size of the array. So the same thing will be applied for negative number as well, because for negative number, the value is negative. So it will just be I plus the negative value of it. So it is basically doing the same thing as I minus the value. And also note one thing, that in the array, all numbers are positive. So let's have a case where you have your I is at 1 and you have to move 3 times to the left. So your nums of I is minus 3. So as per our formula, we just our final index will be I plus nums of I, which is 1 plus minus 3. So that means we end up at index minus 2. And since in the array, we don't have an index minus 2, so we can just take mod with the array size, and still if the number is negative, we can just add the array size to this minus 2. So for minus 2, you will add a 5, is the array size, and you will get the index as 3. So that means if you move from index 1, if you move 3 times to the left, you will end up at index 3. So let's see that. One time, if you move to the left, you'll reach 0. And for the second time, you'll reach 4. And third time, you'll reach 3. So to handle the negative cases as well, we can just have it like your final position will be I plus nums of I. Also, like we discussed, we just need to take nums of I mod the array length, because after every n steps, you end up at the same position. And for the case where this value is negative, to prevent that, we'll just again add a plus n, and overall we can take a mod n. So adding a plus n and again taking a mod n will not alter the answer, because suppose if we split this into 2 parts, we have something like a plus b mod n. This can be same as a mod n plus b mod n, and then the whole we can take a mod n. So the same thing, if you split these 2 parts according to this formula, we can get something like I plus nums of I mod n. This whole term you will take a mod with n, plus you will have n mod n. So n mod n is 0. So for positive numbers, adding this n doesn't really do anything. But for negative numbers, adding a n will just convert it into positive because all our indexes are in positive. Now let's quickly code the approach. So first, let me take the array size dot length and create an answer array of same size. So now we just iterate on all the indexes from I0, I less than n. So we can see that if nums of I is 0, then in result also it will be the same as nums of I, which is again 0. When we initialize any array, all the values are filled with 0 by default. So we don't need to handle this case at all. We just need to handle these two cases, and they both can be clubbed because of our formula. And we'll see with the dry run that why it works for both positive and negative numbers. So in result of I, you have to fill nums of your final index. So for that, let's first calculate our final index. And index equal to, starting from I, you will move nums of I forward. If this term is positive, that means you're moving to the right. And if this term is negative, then it means you're doing I minus some value. So I'll take a mod. So the whole addition, in case if it's negative, I'll just add a n. And at the end, I'll just take a mod again. So this is the final index where you arrive. So in result of I, you just need to set nums of index where you arrive. And at the end, just return result. Oh, I wrote it twice. Okay. So before submitting, let me just do a quick dry run for the second input. So we have -1, 4, and -1, and we have n equal to 3. So initially, when I equal to 0, this formula will be 0 plus nums of I, which is -1 mod 3, then plus 3 overall mod 3. So this is 0, and -1 mod 3 will be -1 only. So this term will be -1. So to this -1, we are adding the array size. So -1 plus 3 will give you 2. So 2 mod 3, finally you will get index as 2. So from here we can see that nums of 0, you will reach index 2, nums of 2. Okay. So that is for I equal to 0. Now for I equal to 1, we have the formula as 1 plus 4 mod 3. Then again, you will add a array size, then whole mod 3. So from here, you can see that this is 1 and 4 mod 3 will give you 1. So this is 1 plus 1, which is 2. So your answer was 2. And to that, you're adding the array size. And again, you're taking a mod with 3. So from this, you can see 2 plus 3 is 5. So 5 mod 3, which is again same as 2. So you can see that this answer is same as your original answer without adding the plus n. So that's why for positive values, adding a plus n and taking a mod n doesn't really do anything. So here again, your index is 2. So you end up at index 2. And finally, for I equal to 2, 2 plus nums of I. Nums of I is -1. So 2 plus -1 mod 3. Then whole, you'll add a plus 3. And then I can take mod with 3, which is the array size. So 2 plus -1 mod 3 is -1. So this will be 1. 1 plus 3 is 4. 4 mod 3 is again equal to 1. So for nums of 2, you will end up at index 1. So that is how this will handle the indexes for both positive and negative case. So let me submit now. Yeah, and it works. Finally, let's do the time and space complexity analysis. Coming to the time complexity, we are iterating on the array once. So it will just be order of n. And for space complexity, we can just say you're creating an array of size n and you're returning it. So the space complexity will be order of n as well. I also have the code in Python. If anyone wants to view it, I'll add this in the description as well. And let's catch up in the next video.